Hi, and welcome to Fixed Income Securities. And today we're going to talk about interest rate swaps, why we use them, and how to value them. An interest rate swap is really a derivative. And this derivative says that you can switch your cash flow for another cash flow. And the counterparty of this derivative is switching its cash flow in the opposite direction. So often this switch is between a fixed and a floating rate. For example, if you have a bond with a fixed coupon, but you would rather have a bond with a floating rate coupon, then either you could sell your fixed coupon bond, and then you could buy a floating rate bond with the same maturity, but then you would be counting on the market to be liquid enough that you could easily sell your fixed income bond and you could easily buy a floating rate note, right? On the other hand, you could use an interest rate swap. So you could just find a counterparty which would be interested in making their floating rate into a fixed rate. So, and this is a very liquid market. So to find a counterparty is actually easier than to find a counterparty in the physical or the financial bond market. And here we have an example, and you can see that the maturity of this bond is 12 months, and or this swap is 12 months, and it pays a fixed rate every 6 or every 3 months. So there are four payments, and in the other direction you have a floating leg, and this leg is dependent, and this leg's payment is dependent on the floating interest rate. So it might be, for example, the LIBOR, okay, the 3-month LIBOR. And the 3-month LIBOR set at t equals 0 is paid at t equals 3. And the 3-month LIBOR set at t equals 3 decides the payment at t equals 6, and so on. What you take for given is the floating leg, okay? You assume that this floating leg follows the forward curve in the market, and this you can observe. What you don't know is the fixed leg, and you decide the fixed leg such that the present value of the fixed leg is equal to the present value of the floating leg. This way, none of the counterparties in the interest rate swap deal comes out ahead or behind the other party. As time goes by, the fixed leg is fixed, but the floating leg might change because the LIBOR might change in the future. And the value of the interest rate swap deal is just the present value of the fixed leg if you are receiving the fixed leg minus the present value of the floating leg if you are paying the floating leg. Or if you are receiving the floating leg and paying the fixed leg, then the value of the swap is the present value of the floating leg minus the present value of the fixed leg. So the reason why you would enter a swap is to turn a fixed payment into a floating payment, or a floating payment into a fixed payment. You can also have swap deals where you swap to fixed payments, for example, in different currencies. Or you can swap to floating payments, for example, in different currencies. But the most usual way or the most usual reason to enter a swap is to swap a fixed leg for a floating leg. Okay, so here you have a company who pays 5% fixed rate, okay, and you have an investment bank who pays 3-month LIBOR plus 10 basis points. And these might enter a swap where the company pays 3-month LIBOR to the investment bank, and the investment bank pays 4.8% fixed rate to the company. The net payment for the company is the 5% fixed rate before the swap deal. They receive from the swap 4.8%, but have to pay 3-month LIBOR, which means that net payment is 3-month LIBOR plus 20 basis points. These basis points would be the difference between the fixed payment and the fixed receivement from the swap. The investment bank's position would be the 3-month LIBOR plus 10 basis points, which they pay. They receive from the swap the 3-month LIBOR, and they pay to the swap the 4.8% fixed rate, which means that they pay 4.9% every single period. This would be the 4.8% fixed rate plus the 10 basis points extra here. And why would you turn a fixed rate loan into a floating rate loan? Well, the duration of a fixed rate loan is usually several periods. And this means that the higher the duration, the higher the interest rate sensitivity of the bond. So in order to reduce the interest rate risk, you could switch your fixed bond into a floating rate bond, because as you remember, the floating rate bond duration is just the time until the next payment. And if you have a payment every 3 months, which is 4 times a year, then the duration of the floating rate bond is only 3 months, which is 1/4 of a year. So the duration is 1/4, and this reduces the interest rate sensitivity of the bond's price. And the reason why the floating rate bond has such a low duration is that every single payment after the first one is regulated according to the present interest rate in the market. So if the interest rates go up, then the payments from the fixed rate bond also go up. So to continue with the previous example, we have a swap deal going over 12 months with 4 payments. There's a payment every 3 months. And you have a fixed leg, the fixed payment, and you have a floating payment. And here you have the N is the notional value of the bond, the face value of the bond. The C is the coupon rate, and 1/4 means that you have 4 payments during the year. And each of these coupons or fixed payments you have to discount. Okay? And when you discount within a year, you use this notation. Just a linear discount factor. And the floating rate part of the bond is similarly set. You have the notional value of the bond times the implied forward rate, the 3-month rate, times 1/4, because there's 4 different payments during the year. The discount factor is the annualized zero coupon rate, the spot rate. So R is the spot rate here. The 3-month, 6-month, 9-month, and 12-month spot rate. And the payment of the floating leg is the implied future rate. Okay? And what you have is the spot rates, and you can observe the implied forward rates. What's unknown here is the coupon rate of the fixed leg. So what you do is that you, in a systematical way, guess different numbers of C to make the present value of the fixed leg equal to the floating leg. At time 0, the fixed leg is set as such that the value of the swap equals 0, which means that the present value of the fixed rate or the fixed leg and the present value of the floating leg is equal. However, as time passes, interest rates change. At time 0, the fixed leg is set as such that the value of the swap equals 0, which means that the present value of the fixed rate or the fixed leg and the present value of the floating leg is equal. However, as time passes, interest rates change. This affects both the spot rates, which is used for discounting, and it affects the implied forward rates, which affects the payment from the floating leg. And if you receive the fixed leg and you pay the floating leg, then the value of the swap is the present value of the fixed leg minus the present value of the floating leg. If you receive the floating leg and you pay the fixed leg, then the value of the swap for you is the present value of the floating leg minus the present value of the fixed leg. And I think we need to show this in Excel. So here we have the example, and we are in Excel, and we are going to value an interest rate swap between a fixed leg and a floating leg. And what we are given is the spot rate, and you see that the 3-year spot rate annualized is 3%, and the 6-month spot rate annualized is 3.5%. So the yield curve is upward sloping until the 12-month spot rate. Okay. What we are also given is the notional value of the swap. This notional value would often be set equal to or very close to the value of the bond you would like to change from a floating rate bond to a fixed rate, or from a fixed rate bond to a floating rate bond. So what we need to do is to first find the fixed leg coupon rate, which makes the present value of the fixed leg and the present value of the floating leg equal to each other. So the difference should be 0. But let's start at the beginning, and we have the spot rates, and from the spot rates we can find the implied forward rates 0 month into 3 month. That first implied forward rate is just the spot rate. However, the next one, the implied forward rate starting 3 months from now, and which is valid for 3 months, has a different value than the spot rate. And what we do is that we use this formula, and we have the discount factor, or the interest rate for 6 months, and this R6 is the annualized, so we need to just take half of that because it's the 6-month interest rate. And here we don't take into account the compound interest. If we are working with years, then we are taking into account compound interest. And this, the geometric difference between the 6-month rate and the 3-month rate, or discount rate, minus 1, is the 3-month implied forward rate for 3 months. But we usually state them in annualized terms, so we have to times 4, because we want the annualized rate. So if we put in some numbers, then we take the 6-month spot rate times 2/4 to get the 6-month discount factor, divided by the 3-month spot rate times 1/4 to get the 3-month discount factor, less 1. And here it should be times 4. And the answer is an annualized 3-month into 3-month implied future rate or forward rate of 3.97%. And if we do the same for the other implied forward rate, then we see that this is valid. The R9 is valid 3/4 of the year, and divided by the discount factor for the first 6 months, which is the R6, less 1 times 4 to get the annualized, and we get 4.91% implied forward rate. And the last forward rate is the 9-month into 3-month implied forward rate of 5.83%. So why do we need these implied forward rates? These implied forward rates decide what kind of expected payment we get from the floating leg of the swap. So for example, if we have a notional value of the swap of 1 million and we have 0-month into 3-month implied forward rate of 3%, then we take the 3% divided by 4, because it's only a 3-month rate, times the notional value. Then we get a coupon from the floating rate of 7.5 thousand. And we see that the implied forward rate curve is upward sloping, so we expect the payments to go up, right? And we do the same for every single payment. We use the implied forward rate, the 3-month implied forward rate, times the notional value, and divide it by 4, because we have 4 payments per year. And that's why we need the implied forward rate. When we discount these cash flows, we use the spot rates. And here, the present value of the first payment, the 7,500 coupon, is 1,444.17, and we do the same for all the coupons. And remember that the spot rate is quoted in annual terms, so we have to adjust it. So this 12-month rate is 1 year, but the 9-month rate, it's 270 days into the future, into the year, so we have to linearly adjust it. And the present value of the floating leg is just the sum of the present values of the coupons, so it's 43,000. What we do then is to calculate the payment of the fixed leg. And the fixed leg, here we just guess a coupon rate. And we have guessed a coupon rate of 5%, and with a notional value of 1 million and payment 4 times a year, the payment is 12,500, which is 50,000 per year. And the present values of these payments, they are found using the spot rate in just the same manner as the payments from the floating leg. And we use the spot rates and we adjust it for how far into the future it's valid for. Okay, this is the 3-month spot rate, and we sum the present values of the fixed leg And we see that the present value of the fixed leg compared to the present value of the floating leg makes a difference of 5,700, which means that our fixed leg coupon rate is too high. So if we try a 4% coupon rate, we get a present value of 39,000 from the fixed leg payments, compared to a present value of the floating leg of 43,000. We have a difference of negative 4,000, which means that the fixed leg coupon rate, which makes the value of this interest rate swap equal to 0 at the outset, is somewhere between 4 and 5%. And to find the correct coupon rate, we can just go to data and to the solver, and we set the objective function here. The difference should be equal to 0 by changing value of the fixed leg coupon rate. So if we solve, we get a coupon rate of 4.41%, and we see that the present value of the fixed leg with a coupon payment per period of 11,033 is exactly equal to the present value of the floating leg. So the difference is 0. So now we have found the correct coupon rate for this interest rate swap. Another thing to keep in mind is that what if you enter the interest rate swap, and the very next day the interest rates they change. So let's say that the spot curve experiences parallel shift of 0.5 percentage points. Okay, 50 basis points. And 50 basis points is in decimals would be 0.05, and that's half a percentage point. And if we just add this to the spot rates, and this is just a very easy way to add, then we have a parallel shift in the spot rates. They are now 0.5 percentage points higher, which affects the payments here. Just remember that the first payment is not equal to the spot rate anymore, right? Because this first payment, it was set when you entered the interest rate swap. Okay, so this is the reason why the floating leg has a maturity of 3 months, right? The floating leg has a maturity equal to the time to the first payment. So here we have to adjust it to get it back to the original payment. Okay, but let's say the spot rates they shifted upwards by 50 basis points, which means that the interest rates, or the interest payments for the floating leg, which had not been set yet, the expected payments, they are just shifting upwards with the implied forward curve. Okay, and you see the implied forward curve, it shifted upwards as well. And what happens here is that payments, the expected payments of the floating leg, the payments which had not been set yet, they are shifted upwards, but they are discounted by a higher spot rate, right? This payment is discounted by using the 6-month spot rate, which means that the present value of the floating leg, it changes. Okay, so and how does this change compare to the change of the fixed leg? Well, the payment for the fixed leg, it's fixed, right? That's hence the word fixed leg. The payment is 4.41% per coupon, which means that we still have the 11,033 coupon, but the spot rates used to discount these cash flows has increased by 50 basis points, which means that the present value of the fixed leg, it's going down. So the present value of the fixed leg is now 42,900, and the present value of the floating leg, because of the increased implied future rates, is now at 46,300. Hence, the difference is 3,446. And if you are receiving the fixed leg and paying the floating leg, your position is now in the negative 3,000. However, the opposite, if you're receiving the floating leg and pay the fixed leg, then the difference would be plus 3,000. So this is how you value an interest rate swap after the initialization of the swap.